Hey everyone, we're going to be looking at Chapter 8, Section 3, where we will be adding and subtracting rational expressions. So previous to this, we have been multiplying and dividing rational expressions, but now we're going to be doing the adding and subtracting. Seems a little bit backwards, but we're doing this one second because, well, it involves a few of the steps that we needed for multiplying and dividing, and we're going to add to it a little bit more. Before we even look at any sort of crazy examples, let's first talk about back to the basics, to the fractions. And so if we have, for example, something like 1/5 plus 3/5. Well, when we're adding fractions and they have a common denominator, you just add the numerators together, so that would be 4/5. But if we had something like 1/3 plus 1/6, before we could add those things together, we would have to figure out a common denominator. And so here, the least common denominator would be 6. And so to make 1/3 6, we'd have to multiply the top and the bottom by 2. And multiplying by 2 over 2 is just the same thing as multiplying by 1, right? So we're not changing the value, we're just changing the way it looks. And when we multiply fractions, we'll multiply straight across. We'll take the 1 times the 2, we'll get 2, and 3 times the 2 is 6. So then we can add it to that 1/6 we had before. We get 3/6. Then, of course, if it reduces, that would be 1/2. So we're going to use the same idea here for rational expressions that have different variables in it. So let's take a look. Okay, so on this first example, we have 3x minus 4 over x plus 3 plus 2x plus 5 over x plus 3. So just like before, if the denominator already matches, then that's great news for us because we can just add the numerators together. So we have over, the denominator is x plus 3. We can add the numerators together. So 3x plus 2x is 5x. And negative 4 plus 5 is 1. And then we can consider if this factors or reduces anymore. And it does not, so that would be the answer. We also have to figure out where it's undefined, which is just like we did before. And to figure out where it's undefined, you have to look at the denominator. And if anything canceled, back before it canceled. And you'd have to figure out what would make this denominator equal to 0. Because we do not want to divide by 0. That is a no-no. That would be undefined. So to figure out where it's undefined, figure out where that x plus 3 is equal to 0. Well, if I have x plus 3 equals 0, then x would equal negative 3. So this expression would be undefined at x equals to negative 3, so this is how we'd write it, equal sign with a slash through it. X cannot be equal to negative 3. Let's move on to something that does not have a common denominator. Actually, before we do that, let's talk about one thing. Say we go back in time here before we've figured out what everything is equal to. And instead of having addition, we make it subtraction. So if we change the sign to subtraction, well, our common denominator would still be x plus 3, but I think it's a good idea to distribute the negative, so I'm going to change this to a plus sign, but I'm going to distribute the negative as I do so. So now I have plus a negative 2x plus a negative 5. That way, when I add them together, 3x plus a negative 2x is x, and negative 4 plus a negative 5. So I distribute it so I'd remember that I'm really subtracting both of these terms. So negative 4 plus a negative 5 is negative 9. And then in this case, that would be as much as that could be simplified. But to figure out where it's undefined, look at where that denominator would equal 0. And so if I solve that, I would get x equal to negative 3, and x cannot be equal to negative 3. Okay, so say that it wasn't as easy, or we have a problem that's not quite as easy as what we looked at before. And by that I mean the denominators don't already match for you, because, you know, sometimes things in life are harder than other things. So we're okay with this. We're just going to face it and follow some steps here. If we do not have a common denominator, this is what we could do. So the steps for adding or subtracting rational expressions. So you'll want to factor the denominators, denominators completely. Took a long time to write here. Denominators. Sorry, that looks so messy. Okay, factor the denominators completely. The second step would be to find the least common denominator. Going back to that example that we had started with, we had 1/3 plus 1/6. So the least common denominator would be the smallest denominator that I could get that would have these two denominators that I started with as factors. So we picked 6 because I could turn the 3 into a 6 just by multiplying it by 2. But other denominators that could have been included that maybe aren't the smallest or least common denominator could have been 9 or 12 or 18 or 24, right? Because 9, 12, 18, and 24 all have factors of 3 and 6. But we chose the 6 because that was the least common denominator that would work. So that's step 2. Step 3 would be to write each term of the expression using the least common denominator. So make all of the expressions have the same least common denominator. Step 4 would be to add the numerators and simplify. And finally, step 5 would be to figure out where it's undefined. Sorry if my handwriting's a bit messy. Okay, let's look at an example. Okay, so we have x minus 1 over x squared plus 3x plus 2 plus x over x plus 1. So we're just going to follow the steps that I wrote down on the previous little screen there. And the first step would be to factor the denominators completely. So to factor these denominators, this one is x plus 1 and that can't be factored anymore. But this x squared plus 3x plus 2, we can factor that. We would have what multiplies to the last term adds to the middle. So if we have x plus 2, we also have x plus 1. So we've done step 1. We've factored the denominators completely. Step 2 would be to find the least common denominator. The least common denominator, so comparing this x plus 2 times x plus 1, and I compare this denominator over here to the previous one, we have the x plus 1. Well, first of all, look at what's the same. Well, I see they both have the x plus 1, so that's great. But we need that x plus 2. So what we're going to do is, if it needs the x plus 2, we're going to put that right here. But remember, we don't want to change the value of this second expression here. So we're going to multiply by a form of 1. Wouldn't you agree that x plus 2 divided by x plus 2, that whole thing would just equal 1? So really we're just taking x over x plus 1 and multiplying it times 1. So then step 3 would be to write each term of the expression using the least common denominator. So this first term would be x minus 1 over x plus 2, and leave it factored, times x plus 1. And we have plus, so this x times x plus 2 would be x squared plus 2x. I just distributed the x. And then its denominator is now, it doesn't matter which order we put these in, x plus 1, x plus 2. So its denominators match. That's fantastic. Now we just need to do step 4, which would be to add the numerators and simplify. So I'm going to have equals. So my denominators will stay the same. So let's just go ahead and write that, get that out of the way. The x plus 2 times the x plus 1 stays the same. And I have only an x squared. I've got a 1x and a 2x, so that's 3x, and then minus 1. We also need to figure out where is this undefined. So we need to look at every single x value that could possibly make this denominator equal to 0. Well, remember, we would take each factor, set it equal to 0, and solve for x. So if we set x plus 2 equals 0, we'll get x equals negative 2. And if we set x plus 1 equal to 0, we'll get x equals negative 1. So it's undefined for negative 2 and negative 1. Let's look at an example using subtraction. So I've got 2x squared minus 16 over x squared minus 4 minus x plus 4 over x plus 2. But we're still going to follow the same steps we did before. So first of all, we're going to factor the denominators completely. So if I factor this x squared minus 4, that's a difference of 2 squares, so that's x plus 2 and x minus 2. And this denominator is already factored. It has x plus 2. So we need to figure out what is the least common denominator. So we want to compare what we already have. Well, they both have an x plus 2. But the second one needs the x minus 2 that the other one already had. So we're going to multiply the bottom by x minus 2. Whatever we multiply on the bottom, we also have to multiply on the top, so that way we're only multiplying by 1. Because x minus 2 divided by x minus 2 is just 1. Now we're going to write each term of the expression using the least common denominator. So we will have the 2x squared minus 16 on the top. This one is still x plus 2 times x minus 2. Here's that minus sign. And then this x plus 4 times the x minus 2, I'm going to go ahead and multiply that out. So that's x squared, and I'm foiling, so that was x times x. Now x times negative 2 is negative 2x, plus 4x is a positive 2x, and then 4 times a negative 2 is a negative 8. In its denominator is x plus 2 times x minus 2. I want to get rid of this negative, so I'm going to distribute it, so I'll have plus a negative x squared and negative 2x and a positive 8. And by changing this into addition, it's just like what we did before. So let's write it as a single expression. Its common denominator is still x plus 2 and x minus 2. And so we'll have 2x squared plus a negative x squared is 1x squared. We've got a negative 2x. And negative 16 plus 8 is negative 8. But you should always check whenever you're simplifying to see if this top thing factors. And checking this out, is there anything that multiplies to negative 8 that adds to negative 2? Well, as it turns out, that's the same thing as x minus 4 times x plus 2. Well, if we're ignoring the fact, let's make this a little less complicated. We've factored that. So now we have x minus 4 times x plus 2 over x plus 2 times x minus 2. Well, things cancel here. And do you see what it is? The x plus 2's cancel out. So now what we have is x minus 4 over x minus 2. And it is undefined where, go back in time travel backwards. Before we cancel things out, look at the denominator. What x values would make the denominator 0? If I said x plus 2 equal to 0 and solve for x, I would get negative 2. And if I set the x minus 2 equal to 0 and solve for x, I get positive 2. So you get x minus 4 over x minus 2, where it's undefined for x is equal to negative and positive 2. On your own paper, I would like for you to complete the following problem, and just do it on a separate piece of paper, and then whenever you get here tomorrow, just go ahead and put that piece of paper on top of my desk. You can just bring it in and put it on my desk and leave it there. Don't have to say a word. Okay, here comes the problem. Are you ready? I would like for you to subtract this problem and identify x values for which the expression is undefined. And again, on a separate piece of paper with your name on it. Just put it on my desk whenever you get here. Have any questions you need to ask me ready for class tomorrow, and I'll see you then. Bye.